In this next video, we're going to look at from factorization straight out to simultaneous equation. So what is factorization? Factorization is removing what is common. See, when we can't add or subtract, factorization is done when algebraic terms cannot be added or subtracted. We said that we couldn't remember we were dealing with x squared minus x. And we said we can't add this because they are unlike terms. But we said something can be done because when you add terms or subtract terms, it must have the same variable and the same power. If this was 2, then it would be 2x squared. But this is not 2, this is 1. So what do we do in the case? We can't add them. We remove what is common. What is common? X is common. And this is x. Why put back x there? Because we must multiply back whatever you remove that common term to get back the exact term or value that was at the top. So x times x is x squared, and x times 1 is x. Alright, so what is common here? If you look carefully, you'll see that the numbers are common. 2 is common, so we remove 2. We can add them, can we? No, they're unlike terms. So we remove 2. When we multiply back this common term inside of this bracket here, the distributive law that I was telling that you have to remember, 2 times x is 2x, and 2 times what will give you 4? 2. Another way in which you can do that is, if 2 is common, you take out that 2 and you divide the term up there to know what will go in the bracket. You divide 4 by the common term 2, and then you know what's supposed to be in the bracket. So what is common here? Oh, this is simple. 6 is common. Take out the 6. X times 6 is 6x, and 6 times y is 6y. Here, what is common? Number again. 2 is common, so 2 comes out. And you have 2 times 2x. Again, you can divide the 4x by the common term 2, and you'll see what has to go in the bracket. And 2 times 3y will give you 6y. Well, you can do this, minus 5. I'll say minus 5 is common. Because why is a minus 5 common? Because there's a minus 5 there and a minus 5 there. So minus 5 is common, and we have minus 5 times r is minus 5r, and minus 5 plus. Minus times a positive will give you a negative. So minus 5 times t, positive t, will give you negative t. Hey, we did this already. This is x minus 1. 4 here. What is common for the numbers? Know your tables. 12. Is 12 alone common? No, y is common as well. So 12 times 12, you can do it, remember, 144y squared divided by the common term 12y. 144, this is 12. Y divided by y squared, the 1y. So 12y has to go in there. So 12, 12, 144, y times y is y squared. And just a 1 has to go there. 1, anything divided by itself is 1. Okay, you do this. The minus 5 is common. Why is a minus 5p common? We don't want the negative in front here. The negative should be at the back here in the bracket. So minus 5, and remember you have to divide minus 25p squared divided by minus 5p. Minus divided by a minus is a positive, so the minus and the minus goes, we'll have 5 left, so 5p divided p there, plus minus, sorry, this should be a minus 1, because minus 5 times 1 will give us the positive, minus 5 times the minus 1 will give us the positive 5p. If I'm going too fast, you can stop me and ask questions on the video. Okay, highest common factor. What is highest common factor? The highest common factor, ridiculously, is the term with the lowest power. And you can find these examples on page 246. So what is common? We have to factorize these terms because they're all unlike terms. We can't add them or subtract them. So what is common here? For the numbers, the 5 is common. For x, x is common. This has the lowest power. For y, y square is common. So how do we know what goes here? We divide. 10x cubed y squared divided by 5. What is common? X y squared. 5 goes into 5 2 times, so 2 has to go there. X, when you divide in term, you have to subtract the powers. There's a 1 there, so when you subtract 1 from 3, you get 2, so x squared has to go there. And y squared, the y squared cancels, so no y has to go there. And this is how highest common factor works. So 5 times 2 is 10. X times x squared is x cubed. Y times all of this will give you back the y squared. So x goes here. X times x is x squared. We don't put back the 5 because 5 times the 1 in front of x will give you 5. Y times y cubed will give you y to the 5th. 5 times 3 gives you 15 minus 15. X times what? We don't put back the x because there's x there. Y times y squared times y will give you y cubed. Why didn't we put the x? Because if you put the x here, if you put an x there, you'll have x times x giving us x squared. We can't do that. So this example, you will do this example. I'll just give you the common factors. R square is the common one for the top. S is the common one for the bottom. For the s's at the top. 3 is common for the bottom, for the numbers, and P is common for the letter variable. So R square S, 1 goes at the top there because it's the same term, and 3 times 3 will give us 9, and there's a P there, so we don't put it back. So I just did the first term, you do the others. Factorization by grouping is our next topic. This is important for quadratic. So, how do you factorize by grouping? Well, you look for the common terms. We separate these terms into 2. We look for the common term here, which is P. So P comes out. P times X is PX. P times Y is PY. That goes in there. Then we look at the next 2 terms again. Q is common, plus this sign always has to be in the middle there. Q X plus Y. If you notice, the bracket X plus Y is common. So we take out the common bracket X plus Y. And what we'll have here left is P plus Q. What people normally say, you just, if there's when the bracket is identical, put the 2 terms outside the bracket together and put back one of the brackets. So we have this example here. 3a is common. 3a times x is 3ax. 3a times minus 2y is 6ay. Good, that's for the first 2. Plus b is common. B times x is bx, and b times 2y is 2by. So this is 3a plus b and x minus 2y, and that's how it's done. There are examples like these where they already factorize the terms, and you are not to multiply the terms back inside, you are to bring the terms together. So they did half of your work for you. Okay, so moving on from that. So that's how factorization by grouping is done. Our next topic is algebraic fraction. For those of you who can't remember how to work fractions, This is how we do that. Whenever you're adding or subtracting fractions, you must be adding or subtracting fractions before you can use the LCM. So you check between the fraction. What's the sign? Addition. Oh, addition. I have to use LCM. So the LCM here is 6. And how do we solve this? This the denominator divides the LCM and the answer multiplies the numerator. 2 divides 6. 2 divides 6 is 3. 6 divided by 2 is 3 times the 1 at the top. Plus 6 divided by 3 is 2 times the 1 at the top. So this is 3 plus 2 over 6, which is 5 over 6. Here the LCM is 12. You finish it off. So what about this? Where you have variables now. The LCM here is what? 30? 30. Same thing applies. 3 divides 30 is 10. 10 times x is 10x. 5 divided by 30 divided by 5 is 6. 6 times x is 6x. 10 divides 30 is 3. 3 times x is 3x. Add up all this at the top because they are like terms, they are common, they can be added. And we'll have 19x over 30. Simple stuff. What about when the variables are at the bottom, like this example here? Well, the LCM must contain the variable. If there's more than one variable, like this case, the LCM must contain all the variables. So we have here, and the numbers as well, the common letter for the numbers. So this is 12. The LCM is 12x. Watch me at the side, or at the top here. Is the LCM divided by the denominator, and we take the answer multiplying numerator. So 12x divided by x is 12. So this will be 12 times 3. Next one. 12x divided by 3x. X goes with x, 3 goes there, 4. 4 times 4 plus 4 times 4. And 12x divided by 4x will give us 3 plus 3 times 5. So this is 3 times 12 is 36 plus 16 plus 15 divided by 12x. This is 31 plus 36. The answer is 67. 67 divided by 12. And that's your answer. Well, that's not necessarily your answer. You'll have to break that down. You have to put that into mixed fraction. So how do you do that? 12 divide 67. How much time can 12 go into 67? Well, 12 5 are 60. So I'm guessing it goes, I know it goes into that 5 times. The remainder is 7. So we'll put 7 over 12. And that's your answer. We're talking about this example here where we have two variables in the denominator. Well, the LCM must contain all the variables, so this has to be 9 and 8, 9 and 18. 18 is the number for the numbers, the LCM for the numbers, and P and Q, because the LCM must contain all the variables. So the LCM PQ divided by the denominator. This first denominator is 9PQ. That goes, 9 goes into that 2 times, so it's 2 times 7, 14. Next one, LCM divided by denominator, 18P. Well, 18 goes into 18 once. P goes into P. P cancels with the P and leave Q. So it's Q times the 5. The answer is 14P 5Q over 18PQ. Can we add these? No, they're unlike terms. So you will do this one. I'll just give you the LCM. The LCM is 9xy because the LCM must contain all the denominators, all the variables in the denominators. Okay, then there are these type of algebraic fractions, and the LCM here is 21. 7 into 21 is 3. Is 3 times everything at the top. I know some of you do this, put it 3 times the things at the top there, but that is incorrect. You shouldn't do that. You might not observe this sign here if you do it like that, because this has to change to positive, and you'll see that just now. 3 into 21 is 7 times everything at the top. So 3 times 7 is 21m, and 3 times 3 is 9n. Minus 7 times 2 is minus 14n. M. Minus times negative is positive 30n all over 21. So if you had put the 3 there, just the 3, you'll multiply this here and get 7, sorry. You'll multiply this and get a minus 30. You're supposed to get a positive 30. So then we group them. I'm going to put the m at the back, because if I bring this minus 14 here, I'll have a, no, sorry, I thought this was 2. So this is 21 minus m minus 14m minus 9n plus 30n all over 21. Minus 14 and 21 will leave me with 7m, and plus minus 9 and 30 will give me 21n all over 21. This is not finished. There's something common at the top, and nothing that is common at the top is 7. 7 comes out. We have m plus 3n over 21. Alright? Because of multiplication, this 7 here can cancel with this 21 at the bottom. I'll give you 3. So the answer is m plus 3n over 3. Now, I have to explain this. Only when you're multiplying. If you have two terms at the top, not because this 7 is coming with that 21 means you cancel. Or this 21 with this 21 means you cancel. You can't do that. It has to be multiplying a bracket at the top. And also, if even if you're multiplying a bracket at the top and there's a number at the end here, let's say minus 1 was at the end there, you cannot cancel because of this minus 1. It must be an old term, one entire term at the top, and something common, and then only then can you cancel with the LCM or the denominator. Quickly, we're going to look at multiplication and division of algebraic terms. This is very simple, and then we'll stop and make the other videos on simple equation and simultaneous equation. Okay, so when multiplying or dividing algebraic terms, we just simply cancel, and this can be shown like this. A square is a times a. Let's expand all of this. B square is b times b, and c cube is c times c times c, and that is multiplying. B square is b times b cube, times b, and c square is c times c, all divided by a. 1a goes with 1a, so leave 1a there. These 2b goes with 2b and leave a b there. These 2c's goes with these 2c's and leave a c there. So we have a and a b, ab over 1c. Now, you must know that you can only cancel diagonally, that's like this, and vertically, like that. If you can't cancel across like this. if there was another a on this side here, you can't just cancel there. It has to be diagonally or vertically. Okay, what about this example over here? Well, 2 goes into 4 twice. 5 goes with 5. This a goes with 1a and leaves 1. Remember, when dividing terms, we subtract the powers. This a cancel the next a. So we have 2a at the bottom and a square at the top. A times a. 1a goes with 1, the other one goes with the other one. B now. B goes with b. There's another b at the bottom. So we can leave that one. C now. C takes this c cube and make, remember, c times c times c. So 1 c's go and leave the c square. Can anything else cancel? No, sir. So what's left? 2 at the top with the c square. So it's 2c squared. And the bottom is just a b. When dividing fractions, we upturn the second fraction and we multiply by the first. So in this case, we'll have to upturn this fraction here. So it'll have to be p cube x divided by qr, and you upturn this one and you multiply qr divided by p cube x. Good. So the x can cancel with the x. The sorry, what did I do there? This is wrong. It's supposed to be py, not this, py. So let me write it back here to ease the confusion. So it'll be p cube x divided by qr times q square r divided by q y. It's py, not qy, py. So p, why don't I let you do this? P goes with this, pause, and then you try to solve it. Q goes with that q here and leave the r there. The r goes with the r. This thing looks confusing. Okay, let's expand it so it looks more simple. I'm sorry. This will be p times p times p at the top there times the x divided by r times p, q times r. And on this side it's q times q squared times the r there, and at the bottom here is p times the y. So p goes with one of the p and leaves p squared. This q goes with one of the q and leaves qr. This r goes with this r. Good. There's nothing more to be cancelled. So we have here p squared x. We have a q on this side, so we have to put that q. We can put it at the back here anywhere. And then we have at the bottom just y. So when you can't cancel anymore, you multiply the top with the top and the bottom with the bottom. And that's it.